Welcome. My name is Ralph. I work for Netdata. It's a startup. A lot of my colleagues are in Greece. The thing that we build is an observability tool, mostly around metrics, that revolves around an agent that you install on all your machines, and then it will pick up metrics for you and provide a UI to visualize, either on the machine itself by going to the local host's web service, or through a cloud service that basically allows you to aggregate the display of these metrics across your entire infrastructure. And the great thing about it for me is that it also just keeps the data where it's generated. It doesn't ship your metrics off to cloud. It just keeps it there, and the UI works in such a way that when you do a query, it will go to each of these agents that are connected, retrieve the data, and show it to you, and that's it. So you keep control over these metrics. But another feature that it has is something that, or maybe I should say a design philosophy, is something that we are working on to achieve, is opinionated observability. And I will try and take you through my journey towards this philosophy. And then that mostly involves all of the issues that I've found during my employment at various companies, working with metrics to figure out how can I go from a metric to a visualization of that metric or an alert for that metric. And it turns out that this is really a lot of work. So I won't mention the data much after this. I will actually use other tools that are maybe more familiar to you guys, primarily Grafana and Prometheus. But the concept here is not necessarily something that is specific to Netdata. It is something that I think should be explored in all of the observability tools that we use. Metrics. So it's really simple. You want to collect some metrics from a data source, and then you want to visualize them or alert on it. And usually it's in this order. First, you try to get an idea of what your metric looks like. And then once you've decided that this is a reasonable representation of what you're looking for, then you think about alerting on that thing so that you don't have to look at the visualization all the time. But this requires a lot of knowledge. To go from a metric to a visualization or an alert, you need to have institutional knowledge about the service that you're monitoring, or maybe it is a system metric that is common to all Linux systems or Windows systems that you use, and then you need to know about what the metric that is being collected actually means. There is knowledge about how do I actually reasonably visualize this particular metric. Do I use a line chart? Do I use a bar chart? Do I use a pie chart? Maybe I need a heat map, right? So, and then once you figure out how you want to show it, you also need to know how that works in the tool that you use. And not just the visualization tool, but you probably also need to know all about the details of the query engine that the visualization works against. So in the case of Grafana, it has a lot of backends, and one of them is Prometheus. So you have to know about Prometheus query language, and of course later versions of Grafana help you a little bit with some wizard to construct the query, but you still need to know the language because otherwise you cannot use the wizard. So visualization. Okay, so I have all this knowledge. I accumulated it over years, and I've done this many times, so I have that knowledge. But somebody who's starting out, they will need to find this on their own. And there are all kinds of tutorials and blogs. I will reference a blog that has been around for, I think, 10 years now, with a bunch of insightful posts that are still valid. But the core of visualization is usually, I want to have a dashboard that shows me the right charts in the right order. I might actually have multiple dashboards, so I need some kind of organization of these dashboards. Maybe they link to each other. Maybe there is a couple of these drop-downs that allow you to filter or to select metrics so that the charts that you're showing look at one service, and then when you change the drop-down, it looks at another service that has similar metrics, but you don't want to see all of them at once. I call this slicing and dicing. It basically means I want to filter on what I see, and I want to maybe dig into the details. I might want to have a different aggregation of the data. So instead of, let's say, the sum of a metric, I want now to see the average or the maximum. So I need to be able to play with that a little bit. To get to these dashboards, I need to have some IDs. I have a service, maybe it's a web server, or one of my microservices that have an API that use HTTP as the transport medium, and I want to know what's happening in that service. So I want to look at HTTP requests. But then I have to first discover which of the metrics that are being emitted by that service actually represent HTTP requests. And then I need to figure out what I want to know about these HTTP requests. Do I just want to count them? Do I want to figure out something about the request size or the response size? Or do I want to know something about the latency in processing that request? And then, is that stored in a single metric, or do I actually need to combine multiple metrics to get to the result? This is something that is common. For example, you have a metric that says, this is the count of requests, and then I have another one that is the sum of the latencies of that request. If I divide them between each other, I get the average request rate. Request response latency. And again, I want to be able to filter. I want to do an aggregation over multiple metrics. And I need to understand what the aggregation functions mean and if they can be applied for the metric that I'm looking at. Because sum as an aggregation doesn't make sense for all my metrics. And I will get to some examples later. And then when I do an aggregation, I might actually want to not just have a single time series as a result, but multiple based on some kind of property. So in the case of HTTP requests, I might want to group by the response code. So I know the request rate for the successful requests and the response rate for the failed requests. And then I might want to do some kind of transformation. So I mentioned combining multiple metrics, but it might also be that some metric is in milliseconds and actually want to display it in seconds instead. So I need to actually apply a multiplication on the actual data. But first I need to know, what does a metric mean? What does it represent? And I will go through all kinds of properties that you can assign to a particular metric before you can actually start using it. So my example was an HTTP requests metric, right? So clearly it wants to convey to me how many requests were recorded. And this might be done as a counter. There are different types of counters, and I will go into that. But I want to understand how Prometheus stores these counters before I can do something useful with that data. And that sometimes also depends on the unit. the unit of the metric often defines which operations I can apply, and also what will be the best way to represent that kind of metric. And the metric might have a different unit than the one that you want to show. So if you have a count for requests and I have a sum of the latencies for those requests, the end result will have a unit that is in seconds. But the count was just a counter, right? So it is dimensionless. And then finally, if you want to use functions like standard deviation, which is a very common tool that is the go-to tool for many people that want to understand metrics, you will quickly find out that actually most of the metrics in computing science are not Gaussian. So they're not normal in their shape for the distribution, and that means that a standard deviation for these metrics doesn't make any sense. It might, help you a little bit to weed out the extreme values, but it's not a normal shape. So the standard deviation is not as useful as you might think. Even though many of the tools that we find in observability actually do expose this function, it's probably not that useful for computer stuff. And then once I have this metric and I have an idea of the visualization, I also need to understand what are reasonable values. So for example, for a request latency, probably you don't want an API that takes 10 seconds to respond. You have some idea of what a reasonable response time would be. And that's probably less than a second, and hopefully much less than a second. And then finally, the actual volume of the data that you have might determine what the best visualization is. And I will actually show you some examples. So how do we record metrics? So Prometheus has 3 basic types, and OpenTelemetry kind of also has these. There's some more advanced data types, but these are the most common ones. And a gauge is very simple. So if you have a thermometer back home, the way a gauge works is that every time that Prometheus tries to get the value, you will walk to the thermometer, look at what it is saying, and return that value. That's it. That's a gauge. But a counter is different. Every time you want to record requests, for example, you need to keep a counter in memory, and then every time Prometheus comes, you need to return that counter. And it's not a gauge. It looks like a thermometer because you're looking at a number and returning it, but it's different because the service might actually reset that counter after you read it. So you need to know what to do if that happens, if there is a reset, for example. And a counter has different types of properties. So for example, if you have a counter for requests, you can calculate a request rate. For gauges, a rate doesn't really make a lot of sense. And then if you have a counter, it might be recorded as the delta towards the previous value that was collected, or it will just be the raw count, and that is ever increasing. And metrics are never created equal, so some services will show the values as a delta towards the last collected value, and others will just have an increment all the time, and then you need to apply a function to get to the deltas if you want to. And then finally, there's histograms. Histograms, that there's different things that are called histograms. In this case, I mean histogram as a storage type. So the way it works is that you have buckets of counters instead of a single counter. And depending on another property, you put that thing that is being counted in one of the buckets. So again, for request latency, what you do is you look at the value for each and every request, and you have a bunch of buckets that have a threshold. So if I have 3 buckets, one that says threshold is 5 milliseconds, and the next one is 25 milliseconds, and the next one is 1 second. If I have a request that is 0.6 seconds in duration, then I would put it in the highest bucket. If it is 0.2, I would put it in the highest bucket as well, because it is over the threshold of the second bucket. And then if you have these buckets, then you can visualize those buckets. You can do things like figuring out what the so-called quantiles are. So what is the 99th percentile of this particular metric over all the requests that I got? And that's why a histogram is useful. You can reason about a lot of data points without actually needing all of the individual data points in storage. But it also has downsides, and I will get to that as well. And then units. So in many of these systems that we use right now, the concept of unit is free form. If you go to Grafana, for example, it's a drop down. You select it, so you know about the metric, and then you have to select which unit you want to show on the axis. If you look at time, for example, it will show you milliseconds, microseconds, nanoseconds, seconds, hours, and then you have to select one to understand what your chart is going to look like. And even though Prometheus, for some metrics, stores what the actual unit is, you still have to do it yourself. And then the actual unit representation in Prometheus is not standardized. So it's just an indication, and you can use it if you want, but there's no, you cannot apply automated processes based on that value without knowing that that value represents something that you know. So if it says milliseconds spelled out, it is actually the same unit as MS. And this is troublesome. So there's this organization that is called UCUM, and they have published a huge list of metrics in a standard form. So they use SI units to represent most of the units that you would encounter in real life, whether it's in computer science or in other types of sciences. And it also allows you to specify new metrics based on SI units or counters with some kind of annotation. And the open telemetry community has adopted this as a standard for recording metrics. So if you have a metric in OpenTelemetry, it will always use a unit that is useful and can be processed automatically without a human. And then, it also specifies things like a metric unit. So a metric unit is something that is in the SI and can have a prefix like kilo or deci or milli. And not all metrics have this property. And then they also have special units, which are units that are not linear, like decibels for pressure, sound pressure, for example, or the pH scale for acidity. So if I have a unit for a metric, then I can decide how to deal with it. I can use prefixes or not. If I have computer things like bits and bytes, I might actually not use the SI prefixes, but I want to use the binary prefixes that are a power of 2. This is something that you need to know as well. Is this a metric that is counting bits or bytes? Then maybe this is the better prefix. And then, is a unit additive? Well, if you have temperatures, say that you have 2 sensors on 2 different machines, is it useful for me to create a chart that is the sum of these temperatures? One is 20 degrees and the other one is 25, so I can display a line that says 55. But it doesn't make any sense. So no, temperatures are not additive. And percentages also have the same issue. If I have a percentage of utilization of my disk, then it depends on the disk size. It might actually depend on how fast the disk is to understand whether that value is something that I can compare to something else. So no, they are not additive. The only exception is CPUs, which is often expressed in percentages. But the reason is they basically say 100% is one CPU equivalent. And then in that sense, you can say, well, I can easily go over 100 because I have 5 CPUs, so I can have a utilization of 250%. But just because you're using percent, it becomes a problem because now I no longer know what to do. Can I add these things? Can I not add these things? So it might be better to actually have a separate unit that expresses CPU as a thing. Just like we have bits and bytes, CPU should be its own unit because I can add them. And then for metrics, so not just units, but metrics themselves can also have units that might be additive, but the metric itself is not. A very good example is unique counts of things. If I have 2 services, 2 instances of services that measure the unique counts of some value, the value in one and the value in one in the other cannot be compared because I don't know what the root information is. So if I want to know the unique values for the entire set, that might actually be a totally different value than just the sum on the individual counts. And well, I also mentioned temperatures. You can generally not compare them. If I have the temperature of your CPU and I have the temperature of your disk, I'm not sure if I can compare them. You might have an average. You might want to show the maximum temperature, but I'm not sure if it has intrinsic value. You might need to group stuff to understand something about temperature. So that's another issue. So and then finally you go to visualization, and I see that that time is going fast, so I will speed up a little bit. The first example was HTTP requests that we talked about, and I know it's monotonically increasing. There might be resets. It is a dimensionless thing because I'm counting things, and there are many labels. Well, I will just show you the end result of a chart like this. So, and that's this one. So I have a chart that basically shows a chart, some lines for each of the response codes, and I can see that I have roughly, 350 requests a second for 200s and some other values here. And for convenience, I actually use the logarithmic scale here, because if I did not use a logarithmic scale, then I would only see the line, the green line, and then the rest would be smushed together, right? Let me quickly show you what I mean. If I go here and see all these options that I have to be able to do, this is what I meant. Now it's smushed together. There's no value. So I need to know about these things. And there's some other ways to visualize this information. This was request rate, but we also have a histogram for requests, so I can actually show you percentiles. And that looks really nice, right? I have an average, which is calculated from the sum and the count, but I also have these percentiles. So I have the 99th percentile on top, the 95th percentile, and the 50th percentile. And I put it in there because you should know that the 50th percentile is not the average. And also the average here is more accurate than if you would look at the 50th percentile because of the bucketing. But now I have some idea of the latency here. And this is really great in many circumstances, but not all, and we'll show you. But I think that a heat map is a lot better. But you need to know a lot of things to create a heat map. If I go back to my presentation here, I will quickly go through some of the things that you should know. So you need to know about the rate function and whether you should calculate rate first or the sum first. It's actually rate first and then some. You need to know what the difference is between rate and irate. You need to know what the range is that you're selecting on the query. Usually people take 5 minutes or something like that, but it depends on the aggregation interval. These links point to some blog posts that will be useful if you want to know more about this. A lot of data, a lot of information that you need to know. And for histograms, as I explained, you have these thresholds, you have expected values and reasonable values, and then there's volume that is interesting. So if I want to visualize this slide is about the second chart that I showed you earlier with the percentiles. I need to know all these things. But for request latencies, I also need to understand what are my expected values. If I have an API that is fast, then the buckets should be around that value, because if I have a very large bucket and all of the requests would land in that bucket, then I have nothing to show. I will show you the dashboard again. So here it is very clear, right? I have a lot of requests that are in the 250 milliseconds bucket. But if I want to know a little bit more about whether it's 200 or whether it's 150, I would need to create additional buckets around that to have a more precise idea. And you can see that there are also buckets that are 10 seconds and 2 minutes. That is not useful if you want to know if your expected latency is in the 10 seconds range. So you need to create buckets around that if you want to know what is proper. And then there are some other problems. This is the same type of metrics, but with way less volume. See what happens? I have all kinds of gaps. Then this is a percentile chart that doesn't have any value, and then the only reason is I don't have that much requests going. So heat map actually shows me more than the percentile chart. So another example is disk utilization, which is generally expressed as how much time was used in I/O. But the only value that you get from that information is you know how many operations there were. There's some link here. And now this is 3 a.m., right? You are in the observability team or your SRE team, and you need to know all of that information that I just showed you when all the alarm bells are going off, and you need to create that one chart that you didn't do yet. Imagine the stress of having to go through that entire process at 3 a.m., right? So what we try to do at Netdata is create tooling that puts all of that knowledge into the chart. There's some other things that are of interest, of course. How do I create alerts? All of the metadata that goes with that. Configuration management, I created all of the dashboards. Do I put it in version control? Does that work? Can I transfer it to another cluster? Hard in many cases. And then there's cost. It's not just at 3 a.m., but there's an engineer that needs to have all of this knowledge to be able to create your visualizations. What if you just have a tool that has all of that knowledge embedded? Then, you wouldn't need that engineer for that work, and that engineer that is highly skilled and has a lot of knowledge can be put to use in some other part of your development. So I think I try to come up with the case for opinionated observability, and what I mean with that is putting that knowledge that I just talked about into the tool. As metadata. So what I would like to see is that our collectors have all of the metadata that you would need to visualize. And it doesn't mean that it has to be the only way to visualize something or the only way to alert on something, but it should have reasonable defaults. So when you start out, you can just say, well, I need this metric and this metric and this metric, and there you go. I have my dashboard. For Grafana, there are a lot of predefined dashboards. But what if your the metric that you need is not there? You have to create all of this from scratch, and that puts you at a disadvantage. So Netdata tries to visualize all the metrics for you so that you can pick and choose. There is some standardization, as I mentioned, but it doesn't cover this. It doesn't allow you to reason about metrics in the same way as I just showed you. You have to do it all yourself. So if we have more data, then you will start loving at 3 a.m., right? Because your tool has your back. You can do your troubleshooting, and everything is there. Hopefully, that is the goal, and that's what we're trying to achieve in our tool. But I think it should apply to all of the observability tools out there. This is an example of what Netdata looks like. You can see all of these summary dashboards. They are created from metadata that we store in the tool, so you don't have to create them yourself. So it picks out the things that we find important, but it also, at the bottom, lists all of the metrics, so that if there's a metric that you find of interest that is not in the summary dashboards, you can still add it to your own custom dashboard. We also allow you to select how you want to group metrics and the aggregation method, but we have reasonable defaults. So for this particular chart, we say this is best viewed with sum over all of the databases, for example, instead of all the tables or whatever makes sense for the metrics, because there are a lot of labels. In this case, we want to group it by database. And of course, we also have batteries included. So for many of the collectors in Netdata, we include alerts. And in some cases, the alert might not be enabled by default, but it's still there so that you can enable it and modify the thresholds a little bit to your liking, so you can get started easily. And that was basically my case for opinionated observability. And I'm not sure if we still have time for questions.
Take one, two, if you have any questions.
Yeah, go ahead.
So one issue that I have to deal with, so we use Fabric for observability, although we actually do have some Netdata stuff. But one issue I've is we wanted alerting for getting microphone. How exciting. So we had a bunch of servers and we wanted to alert when they were using an excessive amount of disk. But it was defining excessive amount of disk on an individual level for each server was difficult, because for a lot of servers doing basic things, they don't do a lot of disk. So, I'm sure some sensible default works there, but we've got other ones where we're expecting them to use a lot of disk. But the level of disk we expect them to use was hard to narrow down. I ended up trying to look into, what do they call it, like AI solutions, where we were looking back in time for what the average was back, a year ago, and does that work? And I'm just wondering if you have any input on that kind of problem.
Yeah, so what we do is twofold. So when you create alerts in Netdata, you can also filter which metrics you want to have for that alert. But another thing that we do is we have some machine learning. So for each and every metric that we collect, we calculate a what we call anomaly rate, which is a bit for each timestamp for which the data is collected, where we try to decide, was this a reasonable value or was it off in some way? And we have several models to train previous data, and we basically show it. I'm not sure if the screenshot that I had here will actually see it. Yeah, you don't see it. But there will be a bar on top. Maybe you can quickly switch to our dashboards here. No, this one. Well, we actually have a anomaly advisor around this, but it basically there is. Yeah, I cannot easily show you. I didn't. But there will be a bar above each of the data points where we think it is off. And then you can also use this for alerting. So you can say, if this thing is off for a certain amount of time, please let me know. because it trains on previous data. Not a lot of data, but still useful enough to discover spikes. And we also allow you to order stuff by the anomaly rate. You know.
Right. Any more questions for Ralph? Cool. Thanks for sharing, Ralph. Just
Yeah,
give a
no
quick round of
problem.
applause.
Yeah, thanks.